Okay, ladies and gentlemen, you have made it to your final AP Calc unit, and this unit is all about the applications of integrals. So we spent a whole unit using various methods to find integrals. We've studied some of their properties and how they relate to derivatives, and now we're going to talk a little bit more about what are they good for mathematically, right? The first application, we have a little series of lessons on average value. Okay, so you are familiar with averages, I'm sure, from earlier in your math career. So let's say you have a test, right? And you get a 50 on your first test, and then you get an 80 on your second test, and then you get a 98 on your last test because you studied really hard after that 50. So to get the average value of this, you would add them up and then divide by the number of tests you took, right? By 3 tests total. Okay. So the general way of finding an average, right, is you find the sum and then divide by the number of data points, right? And this is useful for a bunch of different reasons, including in this case, figuring out your grade in a class, right? What if instead I wanted to know the average value of a function over a certain time? So say like this problem down here. Say this function represented your speed on a certain time interval. That's not a great example because time can't be negative. But we can imagine an example where that's the case, right? And I wanted to know the average value of this function. So like my speed increases and decreases at different times. It's not constant, in other words. And I want to know what my average speed over the interval is. Okay? That is an integral problem. So the way I would find the average value is I would take the integral of this function from -2 to 2 with respect to x, right? And what this is the sum of all the values of the function. So that's how we get from like derivative back to the original function when we're taking an integral. We're adding up all the individual changes. Okay, so here if I'm just taking the integral of a function, I'm just adding up all the values that the function takes at every single infinitesimal x from -2 to 2. So this is the sum. So this is like the top of my fraction. And then to divide by the number of data points, well, that's just going to be the length of this interval, right? So I'd say 1 over, and then I'm going to do upper bound minus lower bound, so 2 minus -2. So that is how to set this particular problem up. I'll give you the general form. So the average of f on an interval a to b is just the integral, well, 1 over b minus a, so that was my 2 minus -2, times the integral from a to b of f of x dx. Okay, and that's it. That's the whole lesson. And the rest of the math you guys already know how to do, so I'll finish this one. But you'll have an easy time with it as long as you know to set these up. Okay, so I would integrate, and these are all going to be polynomials to start, which is nice. So I get x to the third, and then put a 1/3 in front. If you're made it this far, you've probably done this quite a few times. And then I'll have x squared would be my exponent because I'm adding 1. And then if I took this derivative, I would multiply by 2, so I got to put a 2 underneath. And then I could check real quick, does my derivative equal to my original function? Well, 3 times 1/3 is 1. And then 3 minus 1 is 2, so that works. And then same here, 2 times 3/2 is -3, and then minus 1 is 1. I'm evaluating this integral from -2 to 2, and then this becomes just 1/4 in front, right? And then from here, you'd most likely just want to use your calculator, right? I'm going to write out at least the next step just so you can see it. So you're plugging in your bounds now. So 1/3, 2 to the third minus 3/2, 2 squared. So that's my upper bound that I plugged in. And then I'll do minus another set of parentheses, and then 1/3, -2 to the third, minus 3/2. And that's my solution, right? I just simplify this algebraically, and that's for sure a calculator problem. You want to work carefully as always, because these integrals tend to have a lot of opportunities to make errors with your signs. Make sure you put in a bunch of parentheses into your calculator as you're typing this out. Your result, you should get 4/3. Okay, and that is it. That is how to find the average value. You'll see a couple different types of problems in this lesson, but they all follow the same pattern. They all return back to this is our key formula here.